is perfect.
Hello everyone, welcome back after our short break. And we continue with the second part of our symposium here. Our next speaker is Dr. Baio from ESA, Technical Department Manager R&D at ESA in Bergamo, Italy. He will hold a presentation about the new ESA integrated and modular system of certified instruments for NG and H2 management. You're welcome.
Thank you very much. So, I introduce a little myself. I'm the R&D and Technical Manager for ESA Pyronics. ESA is a company that is located near Milan. We are roughly 30 kilometers, 40 kilometers from Milan. And we make mostly, we are a combustion system provider. So, we can divide our production into parts. One is the equipment and one is the engineering. We make a lot of equipment that are devices that are used on the control of combustion of burners. So for example, our core business is burners. We are burner manufacturer. We make roughly 40 families of burner with different sizes. So you can imagine how many burners we developed in the past and how many burners we have on the catalog. From low temperature application, so we are speaking about bakery system, 250 degrees, 300 degrees, up to 1500 degrees. So we are speaking about glass industries, for example. We are in all the field of combustion except in boilers. It's the only field that we don't cover. Okay. According to the core business that is the burner, we made also other devices that are all the devices that controls flow rate and pressure of air and in general carburant and fuel on the burner. So we have a complete range of devices like pressure regulators, mechanical, so adjusting flow control valves that are motorized and manual. We make orifice flow meters. We make mixers for premix application, so where we need premix burners, for example. We make in the we have also the electronic devices that I don't speak about because I'm a mechanical engineer. My colleagues are much better than me to speak about all the electronic devices. And we make burner control unit. We make pressure transmitters to control the flow rate and pressure on the furnaces. We make sensor actuators. We make UV scanners to control the flame signal on our burners, and we make also proportional regulators. In the engineering side, we are also skid manufacturers, so we can provide complete skid. We make automation, so we make also software. We make turnkey plant on furnaces, and we have also technical services that make assistance, post-selling assistance on the furnaces. I show you in this image two simple applications in the single burner management. So we have an air line and a gas line that goes to the burner. If you see, these are two typical applications that we sell, that is managing the gas according to a pressure regulator. That can be a simple zero burner in the upper example, or a air ratio control regulator in this example. The first one is the simple one, is used for cold air, for example. The second one is used when we have preheated air, or we have, for example, strong variation of pressure inside the furnace. But at the end, what we use for managing air and gas on the burners are these devices. So we have a ball valve in the inlet of the gas, we have a flow meter just to check the flow rate of gas to the burner. We have a pressure regulator. We have two solenoid valves according to the EN 746 standard and other standards, also the American one. We have the DMS and we have the burner, and the flow control valve on manual for rating manually the flow rate of gas to the burner. This is well known on the market because it's, I think, 50 years that we sell this kind of pressure regulators. This is the old version, so the version of 1950, 1960, just to tell you. We have thousands of devices installed all over the world. It's a very good regulator because big membrane, high sensibility in the managing of the flow from the maximum to the minimum rate of the burner. We have an operating pressure to 65 degrees and a maximum differential pressure that is normally 10 millibars of delta P. The benefit is managing the right air and gas ratio of the burner. So with this kind of regulation, we can set maximum flow rate, minimum flow rate of the burner, keeping the ratio in a proper way in all the field of regulation of the burner. This is the actual regulator. In 2014, we managed to update the regulator according to the new gas appliance directive. It is now in Europe gas appliance regulation. And we certified these regulators for the EN 88-1. So the pressure regulators up to 500 millibars of delta P. In this new version, we updated the maximum pressure that was 140 millibars and now is 200 millibars. And operating pressure, operating temperature up to 65 degrees, but increased also at 100 degrees. We have a special version for preheated gas. And the size from the 3/4 inch to 2 inches certifies the M88. These regulators were updated 2 years ago to work with full hydrogen. So according to the green transition, we tried to take all the devices that now are managing natural gas or other types of fuel with hydrogen, so blending from 10% to up to 100%. In parallel with the pressure regulator, we have also the flow control valve that can be motorized, like the L2R valves that you find on the catalog. That is a micrometric motorized valve with different motors according to what you can do. You can do off min max, you can do proportional mode, you can do for 20 milliamps. We have a purified flow meter to check the flow rate of the burners. We have also gas adjuster, manual gas adjuster. So this is the technical background where we started from to develop a new idea of the devices that we are using on the gas line to the burner. So first request from the market, but also first request from our side was the completion of the ESA product range, which is the only device where we didn't make up to now solenoid valves, so shut-off valves. So we decided to develop the shut-off valves by ourselves. Then to have a system that is as pipeless as possible to decrease the cost in assembling, so 3D connection, welding connection, and so on. So this is the second point. More compact, because you know that we are in a very open world, but every time the requests are, I have a building like that, but the space for the combustion system is always less and less. So we started from that point to study something that was compact and more compact than the actual assemblies. Then easy maintenance and replacement is fundamental things to respect when we have to design and to maintain a gas line, and then a flexible system for future devices. So we started with a new engineering of this kind of devices, thinking about also of new devices that can comes in the future. First modification. This is the actual DZR and FCR. So we are speaking about pressure control valve and air gas ratio control valve, redesigned according to the new CheckMate system that we will see after. So they will be always certified for EN 88-1, but the maximum pressure will increase to 500 millibars. And this was one of the requests because it goes in parallel with the solenoid market.
Hello? So,
Two hands.
one for version and one for the microphone.
Okay, the availability of this regulator will be from the end 15, that means half an inch, that now we don't cover, but we will have the new version for half an inch, up to the 2 inches, 3D connection in all the sizes. One inlet and 3 different outputs. If you see, the only difference between the old one and the new one is the body. The body is the novelty of all this system. It's a body that has 4 equal faces, one for the inlet and 3 other inlets, so left, right, and straight on, with the same geometrical shape. So it means that we can exit from that valve where we want, and this is a novelty for the market. It will be also H2, full H2 ready, according to, I don't know, which product standard, because actually we don't have any product standard that covers devices for hydrogen use. It will be something that will arrive as soon as possible, I think, and I hope. And then we will have also a membrane that we will increase of 10% by decreasing the size of the external regulator. So we have more surface internally on the membrane, so more sensibility on the device, but less geometrical dimension externally. This is the new product from ESA. We started to develop a solenoid valve. It's patented. It's a new patent. Now we are in the national phase. Which is the novelty? To have one body of a single valve, but with 2 shutters. So they are 2 independent valves. So we have the first valve, so shut-off valve, and the second shut-off valve, mounted in the same body. This is very important because the dimension of the valve is comparable to a single valve dimension. You will see here the size will start from the 3/8 of inch and will arrive to 2 inches. We have a small one, that is this one, that 3/8 and half an inch. And we have the CheckMate valve, that is the other 2, that start from the 3/4 and arrive to 2 inches. Which is the big novelty that the market doesn't have now. We can couple 2 valves of the same size. So we are used to see solenoid valves that has one bypass exit that normally is smaller than the main dimension of the valve. With this new system, we can couple 2 valves of the same size. So the exit on the side and the exit in the straight direction is at the same dimension. So if we choose, I don't know, a 2 inches valve, we can exit with a bypass of 2 inches and not with a bypass reduced to 1 inches. The valve will be certified EN 161 Class A and will be certified for the American market. So also for the American market, we will have visual indicator up to over 44 kilowatt, if I remember well, and the proof of closure up to more than 120 kilowatt, if I remember well. All the valves as the pressure regulator will be ready for hydrogen use, so in blending or pure hydrogen. And we will have a connector with a LED indicator just to check if the valve is on or off. And we will have also a slow opening system for the slow opening valve, so one fast and one slow. In the same way, we took the standard product that is gas adjuster, manual or motorized, and we use the same system of coupling with the valves in the motorized valve and in the gas adjuster. So, just to enter into the core of the discussion. These are the 6 devices that we developed. So we have solenoid valves, double valve. The single valve, we have the pressure regulator, zero governor. We have the air gas ratio control regulator, so the double membrane regulator. We have the manual gas adjuster and we have the motorized gas adjuster. Which are the combination? This one are one part of the combination that you can do. Now I will show you some combination according to PNID that we can find on the EN 746 or the ISO 13577-2, just to have an idea what we can do. First one, you see
the PNID of the standard. So 2 solenoid valves and 1 pressure regulator regulated by pressure impulse line coming from the air. In our philosophy, we prefer to have the pressure regulators upstream the valves. So in our assembly, we will put the pressure regulation upstream the valves, and we have 2 valves, EM161, at downstream the pressure regulator. There is a spacer in the middle. Why the spacer? Because we kept the dimension of the membrane as in the old pressure regulators that we have now on the catalog. So compact assembly without any pipeless joint or fitting. Consider that we are coupling 3 different devices in a system that has a dimension of 200, 250 millimeters, not more. So we have a quicker assembly, that's flanges and nuts and bolts, just to put it. We don't have to use any sealant on the grid, except the inlet and exit of the devices. So we have reduced risk of leakage from many more connections that we have to do, and we have an easy to replace device. So if we have a break in the pressure regulator, we take out the pressure regulator, we put in the new one, and we close again. So in very few minutes we can make a modification, a replacement. This is the same with a gas adjuster. You see that there is one other device that is a gas adjuster that can be used instead of a spacer. So pressure regulator, gas adjuster, and the 2 solenoid valves. The dimension of the assembly is the same, but we have one more device in the middle. And this is the example. This is, I think, easy assembly to do. Now we can see different assembly that are the novelty of the CheckMate system. So this is a standard one. 2 solenoid valves of the main dimension, main line, and a bypass with a smaller dimension. You can see this kind of application we can do for reduced rate emission according to the ANSI 746, or to feed a pilot burner when we have pilot burner and main burner. So in this way we have a smaller valve as a bypass that feed the pilot burner, or that can make a reduced rate emission of the burner. Or for example, we can use it with 2 different fuels. An example that is very actual according to the cost of natural gas and LPG. I can make a line for natural gas, the big one, and a line for the LPG gas. We will use the first valve that opens for both lines, and we can choose by the PLC the second or third line if we use natural gas or if we use LPG. Okay? This, you can see here the novelty. We couple 2 valves of the same size, with or without the spacer. There is a spacer in the middle. The spacer is needed if you need to go parallel with the 2 lines to give more space between the 2 lines. But we can couple directly the 2 valves. Okay, so to save space, which is the main application of this. You can imagine about the NOx limit that we have to respect now and in the future. Flameless combustion will be a fundamental way to make combustion of the furnaces, and in this way we can manage flame and flameless combustion. So we have a bypass of the same size of the main one, so we adjust one part, the main one, of the flame mode, and the second one in bypass of the flameless mode. We don't have any problem in flow rate because the sides are the same on the 2 lines. Here we have something a little more complicated. So in electronic ratio control management, we have a zero governor. This is our philosophy. Also in the electronic range, in the pure electronic range, you take out the zero governor and you can use the 2 solenoid valves with the motorized valve. And you can read the flow rate of gas and you adjust with the motor the flow rate, the right flow rate to the burner. Normally our philosophy is to use everywhere a pressure regulator and then to have a motorized valve that make the fine regulation to the right lambda. Okay? And in this way you see two different things. One is the pressure regulator, and the second is the air-gas ratio regulator. Here you can see an application where you can manage two different gases in multi-fuel burners. So we have one unique pressure regulator in the inlet and two lines that goes to the burners, one rated on one fuel and the second rated on the other fuel. Or, for example, another application can be a purging management. I assembly the valve in the contrary way, so I enters in the middle of the two solenoid valves and I can make a purge. I close the first valve, I open the second one and I enters with nitrogen, for example, for purging the line. It can be another solution that we can make with this kind of system. This is a simple pipeless valve probing system according to the EN 1643. So we have a double solenoid valve, and in the middle, on the lateral flange, we will put a small solenoid valve with a pressure switch that is linked to the valve probing system, and we can check the leakage of the two main valves to the burner. Other pipeless application, I didn't put any image, I put only the PNID. We can make different applications, every time more complicated, but we can cover coupling 6 different devices, a lot of application. Just to give you an idea of what we save in space and trees and connection, this is an EPD PEX burner. You can find the new one, the right one on the stand, but it's a comparison between the old one. So same devices, the ball valve filters, pressure gauge, 2 pressure switches, the 2 solenoid valves and the zero burner. And now this is the new line. You see that it's more compact, it's the half of the dimension. And we save roughly 2 3D connections. Only 2 3D connection instead of 6 3D connection. So you can imagine also which is the time that you are saving when you have to do the assembly. Availability. This was a strong discussion internally. So the ISO SSV. The SSV is the small safety valve, that is the small one, is already available in the size of 1/2 inch and 3/8 of inch. The ISO MSV, the CheckMate system from the 3/4 to 2 inches, will be available in the first quarter of next year, 2024. The BZR and the SCR with the new design of the body will be ready for the 4th quarter, so for the end of this year. The same for the gas adjuster and the same for the motorized valve. I think, okay, thank you very much.